Welcome back to Wickerson Studios. This is going to be the fourth video on the RealLine, and actually a tutorial of making the script, of generating the RealLine. Not saying people are going to do it, but I thought because people enjoy watching me make things, I'm going to take this and actually pull this in to show you how the script is made. Just give me 1 second. I'll put that to disable instead of not. I thought I had it to disable. Let's go in here and just hit disable. And I believe everything should be off if I hit here. Interestingly enough, nothing is disabling. Maybe I'll just shrink that. Let's select all that and disable. There we go. Now it's gone. I guess I hadn't selected it. I'm going to make that file. I'll probably just make it beside here before I get into intervals. So I've done a little short video on the information that's surrounding the RealLine, and this is actually just the making of it, and I'll build it here in Grasshopper. So let me grab my snipping tool and show you how it's done. Same way it begins almost every time, whereas I consider what I'm going to do in the Rhino window. I'm going to start with points, and this will be in 2 dimensions, so I'm going to start at the 0, 0, 0, and if you don't believe it's there, you can put on your shade and you'll see that that's basically where the 0, 0, 0 is, right where the X and Y axis, lines come together, or axis comes together, the XY plane and the Y finds center. I could leave that, but I think what I'll end up doing, we'll keep it in, we'll put it in perspective window just for fun and take it over. I don't mind looking at it in pen and ink, which is kind of fun. So you have a 3 dimensions, or actually better yet, technical. So we have our point made, and there it is. It's going to select blue, and if I unselect it, it's going to go orange. And I've shown a few shortcuts of that. And I basically want to run a range. Same thing I do almost every time, going in the sequence, grab myself a range, and throw it in. I'll be having a range that defaults, but this time I'm going to go into Maths and do my little creation of a domain. And my domain I'm going to set in a positive and negative direction into the low part of the domain, and then the high part I'm going to default to 3 as an integer, going forward and back on the in each direction. So there it is. That's about the length of what I'm doing. Not too hard to get that started. You won't need to look at it if you take it into line, and I'll take it into curve, and I'll use a polyline because there's no point in a straight line going into NURBS or interpolated. And there it is. We can take off our points. We don't need to see that. Preview off. And we have a line here in blue. What's nice is you don't complicate it. If you go into, say, artistic, you see that line floating around in 3 dimensions, even though it's on a 2D plane. I usually end up grabbing the start and end of those lines because I'll want to do something there. And what I end up making under the vector tab is a vector 2 point. And I'll utilize a Boolean in this that I will bring the start point here to the end point here. And I'll have a vector display over here to show you that one, but you'll see the length of this vector if I start with the vector anchor and the vector length, that it's way over here. It's actually moved outside where it is, and what I want to end up doing in that line that's actually in use, this polyline, my vector, I'm going to basically unitize that vector with a Boolean union, Boolean toggle. What am I talking about? Boolean union. And I'll make it to true, and there we have a nice little line of what's happening here, and a whole bunch of little points to look at, start lines, end lines, which I'm going to take the preview off, and my polyline is a little longer than where I want it to be. What have I done? The only thing I haven't done to this polyline curve is reparameterize it. Let's reparameterize that, and I think we should be good to go. Everything should be in here. Let me take a look through the steps, the end domain 3, and if I set it to 1, there we go. Actually, if I set it to 2, it seems to fit pretty nice, but I actually want it in 3. Now my arrow is in an interesting place, and I find that interesting. Let me see if I've done everything correctly. X, Y, Z, close the polyline. Have I hooked everything up correctly? Start and finish the curve. The vector, I don't want to be looking at that one off, and I think everything should be good. Interesting. Okay, I'm not sure why my vector's there. I've just probably lost point. I'm going to go to the top view and have a look at what we actually have going on here. And I'm visualizing a little early on this start and end line. So let me take this to on, and there's our start and end. And the vector, what I want to do is pull my vector. That's very strange at the start. What if I take my anchor to the start? What if I take my anchor to the end? That's really what I want. Something that looks a little closer to that. Off. So we have this line, and we have this line as to what we want to see. I'm going to visualize only that. And that should be good to go. All right. And if I select those pieces, you can see what's happening. Once again, put it in the artistic. So I had a little bit of funkiness there. There's the vector added to the line at the end to show the direction of it, which I may jump off into. And just for perspective's sake, I'll put it over there. It's got a little rendered shadow, which is kind of fun. Okay, boolean toggle set. Everything's set there. Now all I want to do is build a secondary script that I can start throwing numbers on that real line. And so we can indicate the size and scale of those things. Now, this is something that I use a little bit in sets, going in and grabbing the merge tool, and I can merge in tons of data, and as I add data, it's added to it. So I'm going to pick some points on this line. I'm going to start with double-clicking -2, and that's going to be a little panel tool that's going to merge in this data. And with that data, I'm going to want to set it on the point and the X, and there it is. It's indicated that point. And with that, I'm going to have a little bit of fun with curves and throw on a circle. So I'll take my point and put it on that plane there. It's obviously too big, so I'll double click and I'll choose a very small number slider, 0.05, which should be a good size for a little circle. And there it is indicated. You can see it here, and I'll probably have to switch back to here so it makes a little more sense. I will end up getting rid of a lot of these visualization once I take the surface tool and close it up so I can have something to look at that's solid. I won't need any of this stuff. And there it is, a little blue dot on my real line. And I'm going to orient the plane of that when I get to a text tag because I want to tag that point. So I'm going to go in and hit the 3D text tag. Text tag. And I'm going to put at that location, let's grab the right one. It's interesting, the surface can actually be treated like a plane. So you can go in and you can actually treat it and just do a rotate plane in your vector tab, which is very nice. I'm going to rotate that plane on an angle, but because I want to work in radian, I'm going to type in the pi node. And I'm going to rotate it in a negative direction because I'm starting to understand planes. I'm going to rotate that in a negative 0.5 direction. And there we go. And that should take any text tag that I put on here in that location and rotate it down. And the text I'm going to actually borrow is going to be not only this information here as text, I could bring that over and pop it in to the text tag and have it there down in that direction. But a nice thing to do with that, I'm going to relay that, pull that down here. I'm going to add a concatenation tool because I'm good at working with strings, or better at working at strings. I'm going to fragment that section, but before it, I'm going to put in a, I'll just do dashes this time. And so what I can do is make that as a dashed point that actually takes that line, and I just messed it up, and puts it before that digit. And so that one can become the text tag, and there you go. I pulled it down in that direction. It's not actually exciting to look at as what I want, which is really the underscore line. So it'll kind of draw a line away from that line to show what's happening. So there it is, and the size is a little too big, so I'm going to take it down to a 0.12. And that should pull that down into a decent size. And I stuck it into color, so of course it doesn't read like that. Let's go back, and let's put that into size, and there we go. We should have a nice little indication of that line is a -2 in that direction. And we, of course, don't want to be looking at our plane, so let's take the plane off. And you've got a nice little number indicating that that is 2 on the real line in that direction. We can shrink this down a little bit, and there's our real line. So that's just one thing we can add to it. And now, of course, you can add anything you want. So from -2, I can go in and say, okay, where is -1? And this gets pretty interesting because you start to explore, and there it is on the line. -1 is here, and we could do the same thing for, because we can use m over n as long as n is not 0. Any integer value, any numbers can go into there, and real numbers can go into there. And so let's try an example of that. 1 divided by 3. And let's plug that in and see where that ends up. And there it goes. It ends up a little farther along the line. Let's go in and type in. So this is just a nice way to play with understanding numbers and thinking about them as to what's happening throughout your script. So as long as, I want to get the exact writing of what it is, that M and N, give me 1 second here, within the RealLine, functions so long as, yes, here it is. It can be represented in the real numbers. It's a nice way of putting it. I'll just lost myself within the paperwork. I want to get it exactly right in what I'm saying within the RealLine. Sorry about the slowdown, but it happens sometimes. Here it is, the rational numbers of what we're dealing with here, and so long as n is not equal to 0, it can be expressed in any form of m over n, whereas the m and n are integers. And of course, integers are defined very clearly by 0 or plus or minus 1, 2, 3, 4, 5. So you're moving a little bit beyond in integers, beyond the natural numbers, but you're staying a little shy of what rational numbers are, because you're going to run into trouble with those. Sorry for that little mix-up. Just want to make sure I'm using the exact terminology. Let's plug in 1, so we have these little dots moving along. We may as well plug in, while we're at it, 2, and we may as well plug in 3. So we kind of build ourselves our number sliders as we go. But what's nice is we can, so long as we add these in the correct place in the merge tool, I'll show you what happens here, because you can put the wrong data onto the wrong point if you get it in the wrong order. So you have to look at the amount of numbers, and I'll show you that specifically here. If I jump into here and I try something like the square root of 2, and what's nice is you can actually type in as a number square root, and it runs it. Square root of 2. It actually reads that, which I thought I did not know that. So if I'm going to add that in here, where does the square root of 2 fall? It falls exactly where it has to, and I put it in there. But what I was thinking was I'd be stuck in the math tools, and I'd have to go into expressions. I'd want to go into here. I'd delete these 2, and I'd hard code in something like the square root of 2. And you can do it that way. And the reason I know that's the formula for adding it is because when I double click on here and I go up here, it will tell me exactly what I have to do to get to the square root of 2. I have to type it into that form. So we can do that. And the other way I was thinking was I could grab an expression node. So there's usually 2 or 3 ways to skin a cat. And here we go. Probably not the best analogy in the world. We also could go in and just type in the number 2 and use this notation here of taking it to the caret. I should have noticed that was caret to half the exponent, and that's going to provide the same result as again 1.4142. And so all of those can be plugged in directly. It's just what would be read if you plug those in. Let's follow that to 8. Is you're going to end up with an estimate of what the square root of 2 is, and that's not what I want it to look like. And the same thing happens here. The way to get the square root of 2 in there is to put in the square root of 2. And that's just a little workaround that I was kind of playing with. That's going to fall between 1 and 2, so even though it's out of order in the merge, it still sorts it and puts it appropriately on the RealLine to where it should be. And then I'm going to just type in something that everybody's fairly familiar with. We will use quote, and we can just type in pi because it recognizes pi. It's smart enough to do that, so we'll add that in. Obviously 3.141. It's going to fall a little bit after the 3, and there it is. Now, if we chose to use the expression node again by going in. And the reason I'm encouraging the expression nodes is because we are going to move into programming and obviously going and writing these in different ways. We can just type in the pi, and with that, make sure it only says that. And I think we're good to go with pi. That the symbol and logo, let's follow that up to 9, is actually coming in, but it still reads as pi. It doesn't read as that pi form. So I think it's called LaTeX, which is a really cool program, L-A and then capital T-E, capital X. And it's a system of really getting some nice notation, which I'm going to want to do with calculus later on in this. So there's our RealLine. There's the scripting of it, the concatenation of it, the playfulness of that. I basically generated pretty much what was over here in this system. So I took that to enable. We've got the same thing. And there's a little bit of mix-up as to where this one sits. And I'm curious. Oh, it was just the dashing. I counted a few more dashes here. one less dash here than here. So after doing a little demo like that, showing how it was made, obviously the one on the file is here. It's worth looking at, and I can disable it and enable it, and we can continue right along with the script. We're going to go into a very interesting interval model now, which is going to allow us to use open and closed interviews symbolic of solid, and we're going to cut a script, node script, generating your intervals and what they actually mean, and we're going to be looking into infinities and things like that. So stay tuned. I hope you enjoy it. And that was a little chaotic, a little jumbling, but people requested that I did that instead of just an overview. I'm going to be building a lot of these into tutorials to show the inner workings, little specifics of how to apply a lot of different things in Grasshopper to make some very simple models. All right, so thanks very much for watching. I think my vector display is pretty nice, but then again, I'd have to choose that to get the whole line on the vector display, and it seems to thin out here a little bit because of the width on the other one, because vectors, data visualization in vectors is a little bit different. That vector is not, you cannot see a vector, and without this visualization, if I disable that, you're not going to see it at all, even if you select on that. You need the data visualization tool or display tool in order to visualize your, you have to enable that, and you have to visualize that by clicking it so you see what's going on. All right, thanks again for watching.